Today we're going to talk about graphing parabolas, graphing quadratics. The parabola is the name of the picture, the graph that we get, and the quadratic is the function. Quadratics are the x-squared graphs. We've looked at them a lot when we did our transformations, and now we're going to learn how to graph them. There's three forms of a quadratic function. The first one is vertex form. You're pretty familiar with this already. A parentheses x minus h squared plus k. Our vertex is given to us, it's h comma k. It's the exact same as our absolute value functions. It just has the square in the parentheses instead, or on the parentheses instead. Then we have standard form, which is what we get when we multiply out the vertex form. We have ax squared plus bx plus c. And our vertex we find by calculating negative b divided by 2 times the value of a. And then we plug that number in to find the y. And then the last one is intercept form. Intercept form is when it's factored, and that's another name for it, factored form. A times the parentheses x minus p times parentheses x minus q, where p and q are x-intercepts where they cross the x-axis. So each of these graphs gives us a key feature. The key feature that we get from the vertex form is clearly our vertex, h comma k. From standard form, we get a y-intercept. It's the one thing we can look at immediately and get from the equation. So we get our y-intercept from our standard form. And the intercept form gives us our x-intercepts, p comma 0 and q comma 0. And notice that I didn't put negative p and negative q, so it's going to be the opposite sign, just like our h was. Right? Just like h was opposite, it's going to be the opposite number. It's going to be the opposite sign here as well. So we want to graph these equations. We're going to start with one in vertex form. We're going to follow these 5 steps. We're going to make a t-table. Unfortunately, a parabola is a curve, so it doesn't have slope like the absolute value graphs. So we have to make a table to graph it. Then we're going to put our vertex in the table. We're going to put a vertex in the table. And then we're going to pick 2 numbers that are near the vertex. And the axis of symmetry is the vertical line that passes through the vertex. So let's write that down. Axis of symmetry is our vertical line that passes through the vertex. We'll make that one word. Through the vertex. And once I know a few points on one side of the axis of symmetry, I can reflect those points in that axis of symmetry. Okay, so looking at the equation, y equals 1/2 times x minus 2 squared minus 4. Our vertex is 2 comma negative 4. Remember, it's always opposite of the number that's in there. Because remember, that moves it to the right 2, and right 2 is positive 2. So my vertex I'm going to add to my table here. So now I want to do one of 2 things. I want to either pick 2 numbers larger or 2 numbers smaller than the x value of my vertex. And I like to go in order. In this case, I'm going to do 3 and 4. Okay, so now we're just going to plug and chug. So 1/2 times 3 minus 2 squared minus 4. That's 1/2 times 1 squared minus 4, which is 1/2 minus 4, negative 3.5. Then I'll plug in 4. 1/2, 4 minus 2 squared minus 4. 1/2 times 2 squared minus 4, remember the order of operations. You have to do your exponent. 2 squared is 4 before you can multiply by the 1/2. And that's 2 minus 4, -2. So we'll put -2 on our table. Okay, so now we have 3 points and we're going to graph them. I'm graphing my vertex first. +2, -4, and I didn't put the negative there. +2, -4. And then my axis of symmetry is going to be the vertical line that passes through that vertex. So this green is my axis of symmetry. We like to abbreviate AOS. And then at 3, we're at -3.5. And at 4, we're at -2. And we can reflect it in our axis of symmetry. So if this point here is at -3.5 and it's 1 away from the axis, we're going to put it over here at -3.5. Right here. And then this point here is 2 away from the axis of symmetry, so we're going to go 2 away on the other side. So at this point, I don't feel like we have a really great picture of our parabola, so I'm going to plug in 6 and see what I get. Plug in 6. Just one more number. I'm not going to plug in 5 because 5 is odd and I have multiplying by 1/2, so it's going to give me a fraction. So if I plug in 6, I get 1/2. 6 minus 2 squared minus 4, which is 1/2 times 4 squared minus 4, which is 1/2 times 16 minus 4, which is 8 minus 4, which is 4. So my point at 6 actually comes all the way up to +4. And we can see it kind of helps us to get that third point, especially when we're multiplying by 1/2 and we're stretching it vertically. It gets real wide, and so sometimes we need that extra point to kind of give us a good picture of what it is, because I would have drawn this really wide when it's not as wide as these 4 points here make it seem. So now I'm going to reflect this in the axis of symmetry. So I'm 4 away from the axis of symmetry, so I'm going to go 4 away in the axis of symmetry here. So 1, 2, 3, 4. And then now I've got a much nicer picture of my parabola than I would have had. Now, could I have left off this point, the -3.5? Yeah. So it's wise to think about what you're multiplying by. If you're multiplying by a fraction, you might want to do multiples of that fraction so that you can get whole numbers out. All right, we're next going to look at an example of the standard form. Okay, so we're looking at standard form. Y equals -2x squared plus 4x plus 1. We know this graph should open up or down. The answer is down because we've got a negative in front, which means it's reflected, so it's upside down. We're going to find our vertex. And we find our vertex in standard form by using -b divided by 2 times a. This gives you the x value of the vertex. So that's -4 divided by 2 times -2, which is -4 divided by -4, which is +1. So I'll start my table with a +1. +1. Okay, so that's where my axis of symmetry is. And actually, I could draw my axis of symmetry before I draw anything else, plot any points, because the axis of symmetry is a vertical line where x equals 1. So I'm going to draw this axis of symmetry here for us, so we kind of get an idea where everything is centered. Now, if my x is at 1, I can choose to plug in numbers bigger or numbers smaller. It does not matter. You just It's up to you. So I'm going to pick numbers smaller because it's easier to plug in a 0 and a -1 than a 2 and a 3. So 0 is really easy. So I'm going to plug in numbers smaller than 0, 0, -1, maybe even 2. Okay, and then I'll just use the axis of symmetry to reflect them and put the symmetrical part on the other side. So when I plug that in, I'm going to plug in x equals 1, -2 times 1 squared plus 4 times 1 plus 1. Order of operations, -2 times 1, 1 squared, and then multiply by the -2, plus 4 plus 1, -2 plus 4 plus 1, that's 2 plus 1, which is 3. So my vertex is at 1, +3. And I plot that on my graph. Now I'm going to plug in 0. When x equals 0, y equals 1. Right? This number, because this term will drop out, this term drops out, and all I'm left with is 1. We shouldn't have to actually plug that in physically. So I get 1, 0, 1. And then when I plug in -1, I get -2 times -1 squared plus 4 times -1 plus 1. -1 squared is 1 times -2 minus 4 plus 1. -2 minus 4 plus 1, -6 plus 1, -5. And so I'm at -1, -5. 1, 2, 3, 4, and 5. And I think that's enough. I can see that I have a stretched graph, and it's going to be easy enough to draw it with those 3 points. Okay, so we want at least 2 points on one side of the axis of symmetry, and then use the symmetry to get the rest of it. So let's see, this point here is 1 away, and so I'm going to go on the same y value and go 1 away over here. And this point here is 2 away from the axis of symmetry. So I'm going to draw it 2 away on this side, and then I'm going to connect the dots. Hard as that is, it's not as easy as it looks on a stylus and a pad. And there's my pretty ugly looking parabola, but it's correct. And our last form is intercept form. In intercept form, we're given the 2 points where the graph crosses the x-axis here, and our intercept is halfway between them. So we can find that halfway point by averaging the 2 intercepts, adding them up, dividing by 2, and sometimes we can just eyeball it and look and see, okay, this is like the halfway point. But we'll do both and verify. So my x-intercepts come from taking x minus 2, setting it equal to 0. And I get x equals 2. So I have the point 2, 0, 2, 0. And then I have x plus 6 equals 0. So x equals -6. So I have -6, 0. -6, 0. So I'm going to put those on the graph and help us visualize where halfway is, and we'll see if our formula works. So 2, 0, and -6, 0. Okay, well, to me, halfway looks about here, right, at -2. Doesn't that look about halfway? So let's see. Let's take 2 plus -6. To find the middle, we add them together and divide by 2. That's -4 divided by 2, which is -2. So an x value of -2 is our axis of symmetry, which is where we thought it would be. But that only gives us the x value, so we have to plug it back in to find the y value. So we're going to plug it into the equation. 1/4. Sorry, that doesn't show up very well anyways. 1/4 1/4 times -2 minus 2. I'm plugging in -2 for x. And -2 plus 6. So I get 1/4 times -4. -4 times 4. And this parabola should open up because there's no reflection on the x-axis. And 1/4 times -16. Which is 1/4 of 16 is 4, so -4. So my vertex is at -2, -4. And that's usually enough. The only time we probably want to get extra points is when the two intercepts are like right next to each other. Then you probably want to get another point to graph it. And there you have it. That is how to graph an intercept form.